Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about forecasting systems. This episode is based on a tech blog titled Forecasting Models to Improve Driver Availability at Airports, published by the engineering team at Uber. Throughout this episode, we will explore this topic from both the business and the data science angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Uber is one of the world's largest ride-sharing platforms. It operates across over 70 countries and generates roughly $40 billion in annual revenue. Airports alone account for about 15% of its global mobility gross bookings. That's a huge slice of the business, and it's a segment that operates completely different from the rest of the city. Here is how airport pickups work at Uber. Drivers enter the airport and join a first-in, first-out queue. Basically, it is a holding area on or near the airport property. They wait their turn, receive a ride request, then navigate to the designated pickup zone. Simple enough in principle, but in practice, airports are some of the most chaotic demand environments Uber deals with. Think about this. The demand is not smooth. It spikes when flight lands, and then dips in the gaps between the arrivals. And the demand can swing dramatically based on weather delays, holiday travels, or late night schedule. And unlike city trips, where a driver can just cruise in a neighborhood and pick up demand organically, airport drivers are locked into a queue. They can't see what's coming, and they have to commit to the wait. This creates two distinct failure modes. In the first one, there could be too many drivers, and drivers are sitting idle for extended periods. On the other side, it could be too few drivers, where riders land and their app spinnings, but the wait time will simply climb and it will result in higher cancellation. Both of the failure modes are essentially caused by the same underlying problem. Nobody have good information about what's about to happen at the airport. That's a gap where the team set to close. They need a robust system to tell the drivers what is going to happen in the near future. Now that we've understood the business problem to solve, let's dive into the technical side to see how the team tackled this challenge. Within the forecasting system the team built, there are three models involved. They are called ETR, EPH, and driver deficit forecasting. They address the problem at three different levels. How long will I wait? How much will I earn? And when does Uber need to intervene directly? Let's go through each one of the model, and then we could have a better understanding of the system. The first model is called ETR, stands for Estimated Time to Request. It answers the most immediate question a driver has before entering the queue. How long until I get a ride offer? The team's original approach was heuristic-based. Estimate the queue's length, forecast demand per minute, and divide one by the other. The problem is that combining two separate models with handcrafted math between them will compound errors. And that compounding would worst in the 0 to 15 minutes range, which is exactly where timing matters most to a driver making real-time decision. So the team replaced the whole thing with a new single end-to-end trained model, using actual observed wait time as the training target. This model integrates multiple data sources and processes them in real time. Along the way, the team addressed the challenges like data inconsistency and real-time feature availability. With all of those solved, this new ETR model achieved a 30 percentage point improvement in accuracy for that short wait window. That precision translated directly into better driver decisions and less unnecessary congestions in staging lot. After talking about the first estimated time to request model, the second model is called earning per hour, which is EPH for short. Well, the previous model ETR is about time. The EPH is about money. Specifically, whether going to the airport right now will actually pay better than staying in the city. The key design decision on this model here is not to just predict a single average earning number, but to model the full distribution of possible outcomes using a deep Gaussian mixture model. The reason is that airport earnings over any given hour are genuinely variable. Some drivers will get multiple high-value trips. Others might hit a slow pocket and earn very little. The distribution often has a heavy left tail, so if you only show drivers the mean, you hide the uncertainty, and that can push drivers into queuing during periods where outcomes are highly unpredictable. So here, the Gaussian mixture model fits multiple Gaussian components to the earning distribution simultaneously, each with its own mean and variance. In this way, the surveyed results will not only have the mean value, but also the variance and the likelihood of the range. With this approach, it provides the driver much more informed information to make the decision. The last model here is the driver deficit forecasting. With the first two models are reactive, meaning that they are designed to help drivers make better decisions when conditions change. The driver deficit model is more proactive in terms of it predicts when a shortage is about to happen, and then it will trigger Uber the system to act early on, pushing notifications to nearby drivers to reposition before demand peaks. This part is framed as a time series forecasting problem. Given current and recent marketplace conditions, predict driver deficit over the next 30 minutes at a 5-minute resolution. On the modeling side, the team uses the transformer encoder architecture, where the encoders are well suited here because they can capture dependencies across the full input sequence simultaneously, without needing to step through the forecast autoregression. The model is still being refined by the team ahead of a full production release, but their early experiments shows positive results. Now we have discussed both the business problems and the technical solutions. Let's wrap it up. In this episode, we discussed airport marketplace at Uber suffers from demand volatility that standard city models aren't equipped to handle. The team's response was a 3-modeled forecasting system: the ETR to help drivers calibrate queue wait times, EPH to help them weigh airport versus city earnings, and the driver deficit forecasting to proactively reposition supply before shortage materialize. What made this system work was to design each model around the specific decision it needs to support, rather than building one generic model and trying to apply it everywhere. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.